So next we'll be hearing from Tony and Subodh from Phoenix Integration. Title of their presentation is ModelCenter MBSE, the bridge between systems engineering and multi-fidelity analytical models. Their abstract is, this session will describe and demonstrate ModelCenter MBSE, an analysis integration framework for CAMEO Systems Modeler, Rhapsody, GENESYS, and PTC Windchill Modeler. ModelCenter MBSE allows engineers to integrate analysis tools with any SysML model element to validate system behavior, verify requirement satisfaction, and perform trade studies to optimize system design, resulting in reduced costs, shortened development times, and higher quality product rollouts. So I believe Tony will take the ball.
All right. Subodh, you with me?
Yes, Tony.
All right, perfect. Let's get started. So most people remember the dawn of mobile phones when they basically were large blocks that could make calls and take calls reasonably well. At some point over time, the phones evolved. The new phones could not only make calls, they also evolved with new capabilities that you didn't even know you needed, but can't live without. Emailing, texting, cameras, to name a few. Apologize here, I'm fighting with a participant panel that's in the way. The same can be said about today's systems engineering solutions. Today's systems models do a great job of capturing the behavior requirements and structure of your product's design. But what if they could do more? What if they could connect your company's existing digital assets, mission, physics, cost models, so that the subject matter experts create, regardless of where they create these and where these models reside in your organization, these models can be part of your MBSE infrastructure. So that you can perform high fidelity behavior and trade studies, and which can be included in all your systems engineering analysis. So my name is Tony Davenport, and as you heard, I'm the North American Regional Manager of Phoenix Integration, along with Subodh Chari, one of our applications engineers. We are going to give you a high-level overview of ModelCenter MBSE capabilities and break down an example of CAMEO Systems Engineering integration with ModelCenter MBSE. So today, we're going to cover an overview of MBSE integration capabilities and provide these examples in both PTC Windchill Modeler and CAMEO. If you do have questions today, please feel free to type them into the chat window. One of our colleagues, Dave Mastroacco, is also on the call with us, and he's going to capture these questions for any that we can't quite get to by the end of the call. So I know we can't do a show of hands, but as a systems engineer, how many times have you struggled to find reasonable values to put into your systems engineering model? Or as a subject matter expert, perhaps someone building analytical mission or cost models, how many times have you said, I'd love to have better access to my project requirements and system engineering models? ModelCenter MBSE answers these questions by directly connecting the systems engineering solution, the subject matter expert's digital models, and essentially turning the digital shred into the digital thread. As anyone in systems engineering knows, one reason for doing a systems engineering model is to determine if requirements are satisfied. With ModelCenter MBSE, you can create satisfied relationships and share these requirements with your experts' digital models directly. Utilizing ModelCenter MBSE, you can not only integrate with your subject matter experts' models, no matter where they reside in your organization or supply chain, but you can execute their models and validate the requirements in your system model. Once the analysis has completed, you can see the values in your systems engineering, how the values in your system engineering model have changed, and if those requirements have been satisfied. Easy to read, green checks for satisfy and red for not satisfied. Our latest version of ModelCenter MBSE can also do conditional requirements for times when you have requirements that are not as simple as pass or fail. Moving forward, we can follow very similar steps to connect opaque behaviors in CAMEO to ModelCenter analysis by simply selecting ModelCenter as the language for specification, then using the same link UI editor that you're familiar with possibly familiar with in ModelCenter. And if you're not familiar with opaque behaviors, they can be thought of as templates that can be assigned to any action within an activity diagram, for example. What that means is that you can more quickly create activity diagrams to simulate the behavior of your system under different use cases or operating conditions by using predefined opaque behaviors. Normally, CAMEO supports certain opaque behavior languages, but generally speaking, you're quite limited in what you can connect to, and for the most part, it's only scripting tools and languages. With ModelCenter MBSE, you can connect your actions to any tool or scripting language, giving you a lot more flexibility in terms of what tools you can use to simulate the behavior of your system, as well as the ability to connect actions to high-fidelity tools, such as FEA models or finite element analysis models, or entire ModelCenter workflows with built-in logic that can kick off multiple analyses. Essentially, you can make your simulations even more useful and powerful. So let's say you discovered an unsatisfied requirement or a change request comes in. Utilizing ModelCenter's multidisciplinary analysis and optimization algorithms, you can perform sensitivity, design of experiments, optimization, risk reliability, also known as probabilistic analysis, with the use of ModelCenter's built-in algorithms and post-processing decision-making tools to find a solution for those requirements. Finally, ModelCenter MBSE also supports Teamwork Cloud projects in addition to local projects. If you're not familiar with Teamwork Cloud, it is no magic, the company behind CAMEO's cloud solution that allows multiple systems engineers to access and work on the same model simultaneously. With ModelCenter MBSE, you can take that level of collaboration further by allowing multiple systems engineers to leverage and benefit from your organization's analytical models. From analysis tools, your analysis tools can reside anywhere within your organization, and ModelCenter can do remote execution, which means that your analytical models can continue to reside with the subject matter experts, that is, the teams behind creating and maintaining them, while being integrated into your system engineering solutions. So this slide was presented by Mr. Guy Babineau back in 2015, who at the time was a chief engineer at Northrop Grumman and one of our first organizations to adopt this ModelCenter MBSE method. He is now Northrop Grumman's Director of Engineering and Manufacturing Leadership. Per Mr. Babineau's words, Northrop Grumman was able to reduce costs, shorten their development schedule, and improve the quality of their designs. They have also been able to increase the satisfaction of their customers because the connection to analysis has allowed them to rapidly respond to customer requests. So let's spend a minute looking at a fully integrated digital thread. Most organizations will start with requirements. These come from doors or could be built already into your systems model. From there, ModelCenter MBSE acts as a bridge to analytical models and manages the execution of the analytical models. As mentioned, you can then begin to play what-if games with your systems engineering solutions via ModelCenter MDAO algorithms to find the best combination of values that satisfy your requirements and behaviors. Once you've met your requirements, you have an option to update your model, your system model, with the new values, or create a new model, a new instance of your systems model with these new values. Now we'll walk through a recent ModelCenter model represented by Kentaro Sugiyama of Northrop Grumman. Each box you see on the workflow is a subject matter expert simulation model or a nested workflow that they've created. So in this case, you may start with a mission solution that defines your design space. This may include a descriptive systems model. Then propulsion models that are from a supplier are attached. Keep in mind that these propulsion models may reside at the supplier. Within ModelCenter, they are black boxed. They run at a supplier with the supplier software, with only inputs and outputs exposed to Northrop Grumman. The supplier's IP never leaves the supplier, nor is Northrop Grumman's IP shared with the supplier. However, Northrop can benefit directly from the supplier's expert model. Next, internal structural and design groups provide their models, as well as aerodynamics and their analysis teams. And finally, mass properties. In fact, this can also include cost models of so that Northrop engineers can measure cost per performance. In this slide, you can now see the running workflow that was just described in that upper right-hand corner. As this video plays, you can see that ModelCenter has direct integrations to major CAD solutions like CATIA, NX, Creo, etc. So as the workflow changes, it updates the geometry and other simulation solutions to include high-fidelity FEA, CFD, electrical models, etc. The real value, however, comes in the bottom left-hand corner, and the ability to make decisions against a large swath of data from the trade spaces created. You can do comparisons of inputs and outputs, for example, to maximize performance versus cost, weight versus fuel economy, etc. ModelCenter provides you with the ability to post-process the data and explore the best solutions for your product that meets and exceeds your customers' needs. Since this is an MBSE meeting, let's focus on the systems engineering solution. By customer demand, the four most popular solutions you see have bidirectional integrations with ModelCenter. For systems integration solutions not shown, we can still integrate with them to extract information. For example, we have demonstrated how information can be easily pulled from a solution like Sparks or Innoslate. At this point, I'd like to hand over the presentation to Subodh Charity, who will walk you through a demonstration with ModelCenter MBSE and CAMEO. Subodh?
Thank you, Tony. For this particular demonstration, we are going to look at a turbofan model. So this is a simpler representation of a turbofan model where we are looking for a performance close to a GE90 engine. So this is the turbofan model, the structure diagram in CAMEO. Next. That same model we've created in Rhapsody. So we connect to both CAMEO, Rhapsody, and next. Right now, in this part of the demonstration, we are going to look at a systems engineer's perspective. So this is a systems engineer who is going to be working either in Windchill Modeler, PTC Windchill Modeler, or CAMEO Systems Modeler, or Magic Draw. So next. That same turbofan model we've created in PTC's Windchill Modeler as well. So you can see kind of the same structure between these different tools, and we interact with those next. Right click.
Okay.
So this is an overview of the MBSE model. We can see that we've got a decomposition of the turbofan into different parts. We have some important requirements compared to the GE90 engine. So we have some performance requirements. We have added an additional stereotype for PTC over here for the requirements. Just like any other model, you would have satisfy relations between block properties and your requirements. A few of the parametric diagrams in this MBSE model. The yellow blocks over here are the constraint blocks. So in CAMEO or Rhapsody, it would be kind of similar. These particular constraint blocks, instead of just being connected to MATLAB or Excel, they are now connected to higher fidelity simulation tools or any of your in-house codes through ModelCenter. And we'll see how that is done and how you can do requirements verification. Next. So for these constraint blocks, they are connected to ModelCenter workflows or components out on the network. Doesn't have to be on your own machine. It can be at a different location. Also executing on an HPC cluster. We see that the requirement is not satisfied, so we had a false for the TSFC. We will go ahead and launch ModelCenter MBSE. So this is ModelCenter MBSE right there. We click the run button. We get a visual indication that one of our requirements is not satisfied. The systems engineer now can go ahead and change the value properties from within ModelCenter MBSE. And if the system engineer knows changing some value properties is going to help them maybe satisfy some of the requirements, they can do that. In this particular case, we now see that a requirement is satisfied. There are going to be multiple requirements. If you just change a single value, it may actually impact more than one requirement. So this right there gives you a dashboard view of all the requirements in your system and whether they are satisfied or not from within, like in this particular case, within PTC. And now we are connecting to those higher fidelity models and actually executing those from within Windchill Modeler because we have ModelCenter MBSE. Next. Within ModelCenter MBSE, with just a click of a button, you can go ahead and save these values back to your MBSE model. So now that we've satisfied the requirement, we go back to PTC's Windchill Modeler. We'll just refresh the model, and now you'll see at the bottom, the satisfied MC is satisfied is true for all of the requirements. And what has also happened is that when we hit the save button, a design instance of that new design has been saved into our MBSE model. And as we know, the MBSE model is our authoritative source of truth. So we are sending the new design back to the MBSE model as an instance, and then you can have a catalog of those instances and also the status of the requirement satisfaction within your MBSE model. Next. So in this particular case, we are now in CAMEO. This is that same MBSE model, Turbofan. We launched ModelCenter MBSE. So as a systems engineer, you don't want to change a few values. ideally, you want to find designs that are better and you want to explore the design space. Well, you can do that now with ModelCenter MBSE. So we are setting up a design of experiment over here to look at some of our designs, to look at some of the alternatives that we can come up with. So we go ahead and run this particular design of experiment. We have sped this up over here, but it's running the ModelCenter workflow on the back end. We set up the objectives to maximize performance. Red designs right here are the better designs. And so using the different plots that were available generally to you in ModelCenter, you can actually use those same plots now from within CAMEO or Magic Draw or PTC even. And then the systems engineer can actually look at the results and make engineering decisions based on the results that are being shown. In some cases, it may be very obvious, but most cases it is not. So you can use the different plots to guide your decisions. In this example, like I said, the red designs are the better ones. So we would ideally want to go towards the top. That's where we have higher thrust, high specific thrust. And so we could pick that design. We could save that design back to our MBSE model. Right, next. So we looked at things from the system engineer's perspective, where the system engineer can now connect to the models that were built by the subject matter experts. And these higher fidelity models, they can directly connect to those from within the ANSYS MBSE tool. What does it give the subject matter expert? Well, they get a context for their requirements. They get to look at all the requirements within the system and see if anything that they do impacts those requirements. So let's take a look at that next. So we are back to PTC's Windchill Modeler. We are in ModelCenter MBSE. We can actually go ahead and export the workflow that is being executed under the hood right here. And this workflow was created based on the parametric diagram in this particular case. And so you can see how the workflow is auto-created. Now, a subject matter expert can utilize ModelCenter to actually execute this workflow. And in this workflow on the left-hand side in ModelCenter, you can see that we also have the requirements showing up and whether they are satisfied or not. So now, as a subject matter expert, I can actually go in and execute this system model or maybe a subsystem model. I could be working on a subsystem, and if I change certain values, I can look whether the requirements are satisfied or not satisfied, or if any changes that I make impact some other part of the system, I would be able to do that. There's generally always a problem where the systems engineers are working off of different requirements and models, whereas the domain or the subject matter experts are working off of different requirements. That wouldn't happen now with ModelCenter MBSE. Next. So within ModelCenter MBSE, we can take a look at how we would address, let's say, a requirements change. So we begin with the requirement changing within CAMEO. So the requirement has been changed. And so now, if you launch ModelCenter MBSE, you will get a visual indication whether the requirement is satisfied or not. If you look in the bottom left corner, right there, you can see that the requirement is no longer satisfied. So now the system engineer could actually go in there and change certain values to find a new design that satisfies the requirement. But that is not always possible because you're impacting different systems, and sometimes you need to do more design exploration and optimization. So now we'll take a look right here next. So we see now back to the subject matter expert, they get the workflow and they also have the requirements context. They can go ahead and set up an optimization or a design of experiment or a probabilistic analysis within ModelCenter and find new designs. So they go run the optimization, and now within ModelCenter, if you look at the bottom right, they can actually see whether the requirements are satisfied or not. So they could be working within a small part of the subsystem, but still they'll have an idea whether any changes that they make, whether they impact any other subsystem that they're working on. And so now you see that all of the requirements are satisfied. The subject matter expert just needs to hit the save button and save that design instance back to the MBSE model. So the next time the system engineer logs in and loads the MBSE model, they go look for that design instance. They'll find that the new design instance is there and the value properties have been saved, and that new design satisfies the requirements. Next.
Subodh, do you want to take this or you want me to tackle?
You can summarize.
Okay, so I'll just go ahead and summarize this demonstration. And thank you very much, Subodh. So essentially what we saw was a demonstration that ModelCenter can manage many types of system engineering solutions. We made an existing systems engineering model executable. We used a systems model to drive subject matter expert simulations. We validated those requirements using ModelCenter to integrate the system engineering model to those subject matter experts simulations. We uploaded or instanced new systems engineering values into the systems engineering model from the subject matter expert simulations. We allowed the subject matter expert to run detailed analysis against new system requirements. And we used the systems engine to perform a design of experiments. Finally, we managed a requirement change, something that is ultimately occurs quite often once a program is underway. Now let's take a look at a workflow. Let's take that workflow one step further. ModelCenter is an option to move a workflow directly into a cloud server through a few single button pushes. This gives your ModelCenter builders, people who build ModelCenter workflows, direct access to high-performing assets both internally in your organization or in your commercial cloud environments such as AWS, Microsoft Azure, GovCloud, and others. Workflows can be placed in the cloud libraries for access from other workflows or to validate and utilize, And they can also be published so that an analyst, a non-subject matter expert, can utilize the workflow for their decision-making purposes. This means that workflows can be published with variables bounded so they are not utilized improperly. Decision makers could be people in management. Customers need access to your solutions that your company creates and possibly sells to them, or other engineers from different disciplines. The analyst can run the workflows but cannot change the structure of the workflow. They can also perform design of experiments with the workflow to find the most appropriate solution for the problems they are trying to solve. Subodh, do you want to take it from here?
Yes. So now we are in ModelCenter. This is a workflow which is partly local and partly hosted on cloud. So we are looking at the source of some of the subcomponents within this particular workflow. If we go look at the server browser at the bottom, we are browsing on the cloud to look at the components or subcomponents within these workflow that are hosted on ModelCenter Cloud. And you can actually use these components to create workflows. So these are kind of your reusable library of components that you can use to create multiple workflows and execute those. So we make sure that the workflow runs. And we can see that we have on the left-hand side many different variables. So as a subject matter expert, that may be okay for us. But when we publish this to the cloud, we want to minimize that. We'll set the value of one of the variables to 100, and we are doing that for the demonstration purposes to see how we take a look at the error that populates on cloud later on. In this particular dialog on the left-hand side, you get to choose which files you want to package with the ModelCenter workflow that you're going to upload to cloud. So we make those selections. On the right-hand side, we are actually creating a shorter list of variables rather than throwing all these variables over to a non-expert user or to analysts. We are only sending a few of the important parameters and responses and design variables that they can change from the web interface. We choose to publish to ModelCenter Cloud. At the bottom left, we make sure we check that whenever we save this workflow next time, it will auto-publish to cloud. And we go ahead and publish this workflow. So we log into ModelCenter Cloud, then the workflow is automatically published onto the cloud. So now that we've published the workflow on the cloud, as a modeler, we would go in, log in, and make sure that the workflow works. And we know that the workflow is going to fail the very first time because we did set a value outside the bounds. So at in the dashboard over here, you can see all the previously run jobs or your other workflows. So this is ModelCenter Cloud, and you can access it just from a web browser. This is the library of our different subcomponents and workflows. Any engineer within the organization could use these subcomponents to create other workflows. We choose the workflow that we published. Now over here, we see on the left-hand side, the blue variables are our input variables and some of our output variables. We are giving them a list of only a few important parameters so that they can actually analyze those better. So we set up the job name, we set up the cluster, and we choose which HPC queue we want to run stuff on. And again, it could be any of the queues depending on how fast you want the execution to go. And then we'll go ahead and submit this job. When the job is submitted, under the jobs list, you can see and track all the previous jobs or the current running job. And as we expected, there is an error over here. But the good thing is, without you having to go back to ModelCenter desktop, you can actually take a look at where the error is. And right now we can see the error is in the very first component, and that's where we had changed one of the values. So we'll go back to our ModelCenter desktop and fix that value. So we'll set it to a value that we know works. And we'll just hit the Save button. Once you hit the Save button, this is now auto-published to the cloud. If we go back to the web browser, go looking for that particular workflow, now we'll load it, and you'll see that we have the updated value for that particular variable. So now as a modeler, we're going to go ahead and run another check over here. You could also go ahead and run a design of experiments. So we'll choose our HPC queue. Let's go ahead and submit this job. So when you submit the job, it's again, the job is created, and now this time we can track the job and we see that the job has successfully completed. You also have the information where the job ran, what are the values, what are the response values that we came back with. So again, this is on ModelCenter Cloud, and you can actually connect your MBSE models to run on cloud using ModelCenter Cloud. That way, you take advantage of your HPC resources, and you don't need to have all the higher fidelity simulation tools or ModelCenter installed on your same machine.
Yeah, and I'd like to add, Subodh, more importantly, as your workflows mature, these workflows can be accessed by others in your organization. So as specific models become cataloged within ModelCenter Cloud, they can actually be pulled into any workflow for reuse, especially important as you begin to do tie-in systems engineering solutions. So access ModelCenter workflows from cloud. Use web browser. No need for ModelCenter install. No ModelCenter expertise or other modeling expertise is needed. Interface to be used. Accessible from any computer or tablet, Chrome, Edge, etc. So in other words, once these workflows are in the cloud, this will expose those workflows to more people and help more engineers get the benefit of a standardized, automated, and integrated workflow that follows best practices. Spread the benefit of ModelCenter to a larger audience so that they can design the best products. Help your audience interact with your design during a design review rather than just show static charts. Ask what-if questions. In fact, even have customers that utilize your ModelCenter Cloud on sales calls to their customers to help them scope a project. In other words, have your sales teams. So a few plots. Subodh, would you like to speak to these?
Yep. Yeah, so using the web interface now, you have access to all the different ModelCenter plots on the cloud as well.
So basically a few types of cloud responses that are available. We get this question often. So what software solutions can you integrate to within ModelCenter? And our answer is generally all of them. The logos you see before you are the most common solution that our customers integrate. However, Phoenix Integration's philosophy is to provide the end users with an easy-to-use interface, a little bit of training, and you'll be integrating any solution tool in your own bit bucket. In 2016, we did an audit with our customers and discovered over 500+ tools have been integrated, COTS, GOTS, in-house, and every type you can imagine. So to wrap up our presentation, you likely recall that the first generation cell phone and how it was compared to today's cell phones. ModelCenter enables MBSE by connecting these systems models to high-fidelity engineering analysis so you can make better decisions about your products and platforms. So I think we're right at 3:30. I don't know if we have time for questions.
Unfortunately, we don't, Tony.
Okay.
I'm so sorry, both hosts.
That's
Everybody
okay.
has to get to another meeting. But did you capture all the questions in the chat?
I think my colleague Dave did, and if not, here's our contact info, and anyone can please feel free to reach out to Subodh or I, and we'd be very happy to work with you.
Perfect. And this will be out on the site probably in the next day or two.
Excellent. Thank you guys very much for the time today. We appreciate everyone's time and effort here.